Okay, so the last PowerPoint that has to do with numbers is conversions. I was looking up conversions in on Google yesterday, and I couldn't believe it. They're teaching conversions back in fifth grade. Okay, how students to do it. So hopefully, most of you've done done this, so I don't have to go completely over. There's going to be a lot of we're going to we'll go over conversions, what it means, and it's sometimes people don't. When you say the word conversion, people automatically think about the method and not think about what it means. Often in science, we have to make a calculation between a relationship between two different quantities. There are several ways to go about this. For example, if you have the same measure at different scales, like millimeters to meters, meters to inches, and pounds kilogram. So let's take a look at one of these, like millimeters to meters. They both measure length, however, they have different scales in the same system, meters. Okay. This type of relations are exact because I know they're exactly 1,000 millimeters per 1 meter. And what this really means is that there's 1,000 millimeters in 1 meter. And you can draw that like this. Okay. So here's one. So this whole circle represents 1 meter, and there are 1,000 millimeters inside it. So it's a group. Okay. And when we get to stoichiometry, I'll be spending more times about grouping because I think understanding what that conversions are really talking about grouping is very important. But what we're going to do is we're just going to take a look in terms of this relationship in terms of a method. But before I do that, let's just look at how this makes sense. So let's say I have 5 meters and I want to know how many millimeters that is. Well, I have 5 of these guys here. So 1,000, 2,000, 3,000, 4,000, 5,000. So 1,000 5 times is 5,000. And so this makes sense. Okay. So that's you didn't have to do any kind of conversions there. You knew right off the bat what your answer is. And that's always what you kind of want to do is you want to make sure the answer makes sense. Okay, and we're going to see that conversions, they can give you the right answer, but sometimes you don't know if they make sense. Well, we have another way to determine the same problem. It isn't as conceptually as pleasing. Okay, you saw the 5 circles, and it doesn't make sense conceptually. However, this method can be powerful because it helps us know if we may have the right answer. And this is called dimensional analysis or fractional analysis. I'll just call it dimensional analysis of DA. The first, you need to know that this is just simply a technique. It's a shortcut. Okay, it will give you the answer without really thinking if the answer makes sense. We have a lot of these in chemistry. I often call them quick and dirty, where you have a method to come up with an answer without thinking about if the answer makes sense. All right. Okay, these methods have curses and blessings. The blessings are that you may get the right answer. The shortcomings are you may not know that the answer makes sense. Okay, let's do our problem using dimensional analysis. So this is going to be the quick and dirty way called dimensional analysis. So how many millimeters are in 1 meter? Okay, so we have equality that there's 1,000 millimeters equals 1 meter. With this, we can divide both sides by 1,000. We get 1. If we do that, we get 1 equals 1 meter divided by 1,000. Or we can do it the other way, and you divide both sides by 1 meter, and you get 1,000 millimeters per 1 meter. Okay, these are both equal to 1, so both of these are equivalent values, and we call these conversion factors. So both of these are conversion factors for this relationship right here. Well, sometimes we'll be using this way and some way this way. And we're going to see how that works. So let's find out how many millimeters are in 5 meters using dimensional analysis. All right. So one of the key things about dimension analysis is that your final units should be what you expect. So you'll be losing the meters of 5 meters, and what'll be left over is millimeters. Okay, let's try both of the conversion factors to see what happens. So I'm going to use the 1 over the 1000, the other one 1000 over, see which one gives me the right answer. That is my final answer of units of millimeters. Okay, so if you use 5 meters times 1 meter over 1000 millimeters, what we'll find is that the meters times with the meters for meter squared, and then you end up over millimeters, and you can see that you're not left with just millimeters, you're left with this weird thing, meter squared over m, and so you know that this is probably not going to be the right answer, and then you use the wrong conversion. Okay, now if you use the other conversion, the 1000 millimeters over the meter, what happens is the meters now cross out, and you're only left with millimeters. So you'll have 5 times 1000, which is 5000 millimeters, and that's what we want. Okay, so you're pretty sure you got the right answer because you got the right units. Now, you're not totally sure because it doesn't make sense, okay? And a lot of times you can't tell unless you really think about it. Or sometimes you're really sure that you don't have to think about it because you know it just makes sense. Okay, so now let's have 2 different scales measuring the same thing length, and we have 2.54 centimeters equal 1 inch. And the conversion factor could be 2.5 centimeters over 1 inch, or 1 inch over 2.54 centimeters. So what we're going to do is convert 42 centimeters to inches, and so what we want to do is get rid of the centimeters and end up with inches. Okay, so which conversion am I going to work? Well, I have centimeters, so I want to have centimeters on the bottom, so I'm going to use this guy right here. All right. Okay, so it's going to be 42 centimeters times 1 inch over 2.54 centimeters. The centimeters cancel out. So it's going to be 42 times 1 divided by 2.54, or 16.53. We're only allowed 2 digits because this has 2, this has 3, and this has 3. So your answer can only have 2. Scoring. Sig figs 2. This has 2 sig figs. This has 3. This has 3. And so your answer can only have 2 sig figs to 5. Rounds to 16 up to 17. So it's 17 inches. Okay, again, you may have the right answer because it's in the right units. Again, if it doesn't make sense, then you just have to trust your answer. Okay, but I encourage you to think about if it is the right answer. One of the things to help you may think about this answer is that by actually looking at the scale. So, so if you look at the scale, you see that there are approximately 5 centimeters and 2 inches. So when you go, so there's always going to be more centimeters there than inches. So we start out with centimeters and we're going to inches. That means we're going from a lot of numbers to smaller numbers. So here's my centimeters, where there's a lot of numbers, and these are smaller numbers. So this number here has got to be smaller than my centimeter number. So, you know, so 42, and I end up with 17. Okay. All right. So a lot of times looking at the scale, you can actually figure out that it makes sense. All right, so now what we're going to do is multiple conversions. That is not just straight. We don't have a one-to-one relationship between kilometers and millimeters. So in this case, you may, but in this case, we're not going to do that. So we just don't have one path. We're going to have one step in the path. We're going to have multiple steps. First, when you do these, you need to have your appropriate conversion factors. You need to come up with a path, and then what you do is substitute the conversion factors into your path. So here are my conversion factors, and they have to be given to you. Okay, so I have these two conversions. I have 1,000 meters per 1 kilometer, or it's reciprocal, or 1,000 millimeters per 1 meter, or it's reciprocal. Okay, so the first thing I'm going to do is I'm going to change kilometers to meters, because I don't have a direct path to kilometers to millimeters. So I'm going to change the kilometers to meters. So I'm going to use this one here. And then I'm going to change meters to millimeters. So I'm going to use this one here. So I start out with 1 kilometer. And then I'm going to use this conversion. Okay. I'm going to I need to have the kilometers on the bottom so that the kilometers cancel out. So now I have 1,000 meters. Okay. And then, now I have to cancel out the meters. I'm going to use this conversion factor. I'm going to use this one here because the meters are on the bottom, and now cancel out with this. And my answer ends up with millimeters. And there's my answers. And so don't worry about sig figs here. These are all exact values. There's 1,000 per 1 meter. So this is an exact measurement here. All right. So let's say I want to do multiple conversions this time using different units and different scales. For instance, 12 pounds gasoline to millimeters of gasoline. Now this is a weight conversion, and this is a volume, okay, which are completely different. All right, and so I'm given, even if you don't know, know that, you can take a look at the 3 conversions. So I have pounds to millimeters. So I have to go pounds, and then I want to go to grams. Okay, so I need to go pounds to kilograms, kilograms to grams, and then finally grams to millimeters. And so these are the 3 conversions I'm going to use. So first thing I'm going to do is 2 pounds to kilograms, kilograms to grams, and then grams to millimeters. So I have 12 pounds of gasoline, and then I multiply this by this conversion up here. This one here, because pounds are on top, pounds are on bottom on the conversion factor, so they cancel out. I'm not even worried about doing the math. I'm going to do the units first. Okay, then I have kilograms, so I got to get rid of the kilograms. So here's my other conversion. Okay. And I have kilograms on top, so I'm going to put kilograms on the bottom. So that gets rid of that guy. Now I have to get rid of the grams. So I'm going to use this one here. So I'm going to use this one here because I have grams on the bottom. And so you have grams, grams, and your answers end up with being mils. Okay. All right, then you do the numbers. 12 times 2.2 times 1,000 divided by 0.74. Your answer is 7,371. Now you have to worry about sig figs because these aren't all exact measurements. This has a score of 2, sig figs 2. This has sig fig 2. This has infinite because this is exact. So you don't have to worry about these sig figs. And this also has sig fig of 2. Okay. This should be 1.00 here. Okay, sorry. So it's 1.00 mils over 0. So this has a sig fig of 2. So the smallest sig figs are 2, so my answer only can have 2. And so it's 7.4 times 10 to the 3rd milliliters of gasoline. So what this says, that if you have 7.4 times 10 to the 3rd mils of gasoline, it would weigh 12 pounds. Okay. And that finishes conversions. And you'll get a worksheet for that. Hopefully you'll be able to figure it out. If you have problems, let me know. Again, you can find conversions all over the internet, how to do them. Right now, we're not going to be using a whole lot. When the next material we're going to be covering is gases, we will be using conversions in that material, but we won't be using conversions at least for another month or another 2 weeks after that. So the main thing is to remember is that conversions are a method. They can give you the right answer if you get the right units, but you're never really sure if you got the right answer because it doesn't really make sense conceptually. So be free to use conversions, but know that I'm never really sure if you know what the answer means when you do conversions because it's just a method. All right. So that finishes the number bits, and now we'll be getting into chemistry and going into gases.